Hello everyone, now it's me Binod Shrestha and you are watching the Excellent Education channel. In this channel you will be getting a lots of lectures related to the mathematics, and in today's lectures I teach you the theorem number 2 of class 10. Okay, now let's get started. Now here is theorem number 2. The theorem number 2 states that prove that the diagonals bisects the parallelogram into two equal halves. Okay students, and here is the figure. Here ABCD is a parallelogram. Okay students, given ABCD is a parallelogram in which BD is a diagonal. You look at here, this BD is a diagonal. And we know this diagonal, now see you are looking here, this diagonal intersects this parallelogram ABCD into two triangles. One is yellow triangle, now let's see, one is yellow triangle named ABD. Another is green triangle BCD. Okay students, now here you are saying two triangles ABD and BCD. We need to prove these areas are equal. Okay students, now we need to prove triangle ABD equals to triangle BCD. You are seeing here this yellow triangle ABD is equals to this green triangle BCD. And how do we prove it? We have the proof, and in proof we have always statement and reasons. Okay student, now here we need to prove is the yellow triangle. Okay, we need to prove is what? The yellow triangle ABD equals to the green triangle BCD. Okay students, and always remember that when the two triangles are congruent, then their area are always equal. Okay students, now let us take these two triangles. In triangle what? ABD, this A, this is BD, this yellow triangle ABD, and triangle BCD, this green triangle BCD. If you are able to show these two triangles, yellow triangle and green triangle, are congruent, then you can easily say their area are equal. Okay students, so now let's try to show these two triangles congruent. So one number. In one number you see in the figure students, here in the figure AD equals to BC. Okay students, this AD is the side of yellow triangle and BC is the side of green triangle. They are equal. So in one number we write AD equals to BC. Okay students, now can you tell me what is the reason? Now you see here students, this ABCD, it is a what? Parallelogram. And by the definition of parallelogram, you know the opposite sides of parallelogram are always equal. So your reason is of course being opposite sides of parallelogram. Okay students, now let's see the second statement. In second number, now you have just look at the figure again students. Here AB, the side AB of this yellow triangle is equal to the side CD of this green triangle. Okay students, so let's write into number AB equals to CD. Now can you tell me the reason students? Yes, of course, these are also the opposite sides of parallelogram ABCD. So our reason is of course being opposite sides of parallelogram. Okay students, now again you look at the figure students. Now in figure you are seeing this line BD. You are seeing here this BD is the common side of both the green triangle and the yellow triangle. Okay students, so let's write in 3 number BD equals to BD. Okay students, now what is the reason? The reason is being the common side. Okay, now in 2 number we can easily say the triangle ABD is congruent triangle BCD. Okay students, now region, it is very easy because we have all sides are equal. If the all sides are equal, then we can easily say is being as axiom. Okay, now you see here we have shown the two triangles are congruent. As I have already told you, if the two triangles are congruent, then their area are always equal. Therefore, in 3 number, we can say the area of triangle ABD is equals to the area of triangle BCD. Okay, students, the region is of course being the congruent triangles. If the triangles are congruent, their area are always equal. Here you have seen students this diagonal. Now see this BD bisects these parallelograms into two equal halves. That is the area of yellow triangle equals to the area of green triangle. This proves this theorem. Okay students. Okay students, this much for today. Hope you have understood these lectures. Thank you for watching. See you in the next lecture. Till then, have a good time. Bye bye.